So today we are talking about understanding slope. So I've got some stuff up on the board to begin with. First of all, slope is the rate of change, or you can think of it as the steepness of a line. There's several different ways we can find slope. The first way you'll see it written sometimes is the change in y over the change in x. Well, that means the same thing as y2 minus y1 over x2 minus x1. And you can also find it on a graph using rise over run. Now, I should have put this up here, but with all these y's and x's, those are just ordered pairs. You know, when we graph points, it has to be an ordered pair, x comma y. Well, if you have two ordered pairs, you can find the slope of that line. And all you do is you take the x value and you label it as x1 for the first one, and you label the second one as x2. And then for the y value, you label the first one as y1 and the second one as y2. So we are going to look at examples of how to find slope using that formula. But if you're looking at this formula and you're like, what does all that mean? It just means that we took whatever our ordered pairs were. Like if we had an ordered pair at 2, 3, the x1 would be 2 because that x comes first, and that's the first one, and then the y1 would be 3. So the x2s and x1s and y2s and y1s and all that, those are just points. They just come straight from ordered pairs. And the last one is rise over run. And this only works if you have a graph. But let's say that you have a graph that goes between these 2 points and you wanted to find the slope. You could start at the bottom point and count how many spaces you rise up, and then you could count how many spaces you run over, and that would be your slope. You would count up 1, 2, 3, 4, 5 spaces up, and then you would run over 1, 2, 3 spaces over, so your slope would be 5 over 3. All right, we're going to look at more examples of that, but those are just some different ways to describe slope. Also, something that you just need to keep in your brain, a positive slope goes uphill. A negative slope goes downhill, and this is always as you read. So you know we always read from right to left. So if it's going uphill from right to left, it's positive. If it's going downhill, I'm saying that wrong, from left to right. Sorry, guys. If it's going downhill from left to right, it's negative. If it's flat, it's zero slope. And if it's vertical, then it is an undefined slope. So let's look at some problems that you're going to see on your quiz. So it says, find the slope of the following graphs. Now, when we have graphs, I think the easiest thing to do is rise over run. And the way that I remember the order to put it in, like if you're laying in bed, you have to rise up out of bed before you can run to wherever you're running to. Run to breakfast, run to the bathroom, run to whatever. You have to rise up before you can run. So that's how I always remember to do rise first and then run. All right, so if we look at this first graph, I like to start at the bottom point because I rise up first. And before I even do my rise over run, I'm going to look at each graph and I'm going to label whether it's positive or negative. So if I go back here and think about these things, remember from left to right, if it's going uphill, it's positive. If it's going downhill, it's negative. So if we look at this one, it is going downhill. So this one we know is going to be a negative slope. I'm going to go ahead and put a negative on my answer. That way I don't have to worry about it later on or get confused later on. And I'm going to go ahead and do that for each of these. This one's going downhill, so I know this one's going to be negative. And this one's going uphill, so I know it's going to be positive. All right, now I'm going to start at my bottom point. And it doesn't matter which point you go to. I usually just go to the closest one. And so I'm going to see how many I go up and then how many I go over. I rise up 1, 2. I rise up 2 spaces, and then I run backwards 1 space. So this is 2 over 1. The negative actually comes because we're going backwards, like we're going to negative 1 on the x value, so we're going in negative direction. But you can just put the negative in front of it. You don't have to write 2 over negative 1. In fact, you won't see an answer written like that. The negative will just be for the whole slope. So that slope is a negative 2 over 1. You could also just write that as negative 2. You don't have to have the 1 on the bottom. All right, let's look at this next one. Again, we're going to find the slope, so we're going to do rise over run. We already said that it's going downhill, so we know it's negative. And then I'm going to start at the bottom point, and I'm going to see how many I count up and how many I count over, rise and run to get to the next point. So I'm going to rise up 1 space, and then I'm going to run backwards 1, 2, 3 spaces. And remember, when you go this direction on the x-axis, if you look at your x values, they are negative. So that's where that negative comes from, but you can just leave it in front. So our slope here is -1/3. All right, and then let's look at the last one. Again, we have a graph, so we're going to use rise over run. We've already said it's going uphill, so we know our slope is positive. Now, if you look at this one, it doesn't give you points, but that's okay. All you have to do is find a spot where it crosses the grid. So if I just look here, when I say crosses the grid, I mean if you look at the grid, it has to cross right there where the 2 grid lines touch. You can't have a line that looks like this and say that there's a point right there. That doesn't help us because it doesn't cross the grid. So this graph is kind of misleading because it kind of crosses everywhere. All these points work. But let me go back and show you on a different graph. Like if we looked at this graph, we couldn't say that there was a point right there because it does not cross the grid. But we could say that there's a point right there because it does cross the grid. So are y'all seeing how to label your points? You can't say that that's a point because it doesn't cross the grid. You can't say that that's a point because it doesn't cross the grid. But you can say, well, I'm not really seeing any others on this one. All right, so when you try to label your own points, you have to find things that cross the grid on the graph. And it doesn't matter which 2 points you find. I'll show you what I mean, but I'm going to go from this one to this one. So I'm going to rise up 1 and I'm going to run over 1. So my slope is +1/1, which can just be written as 1. But let's say that you use this bottom point and then you use this point. That's fine too. You rise up 1, 2, 3, 4, 5 spaces, and then you run over 1, 2, 3, 4, 5 spaces. And if you set that up 5/5, that also reduces to 1. So when you pick your points, it doesn't matter which points you pick as long as they cross the grid and you reduce your answer. All right, so that's how to find slope from a graph. Remember, you always rise up before you run over. Now we're going to find slope from a t-table. So it says find the slope of a line that goes through the following points. Now again, slope is the change in y over the change in x. So what we're going to do for this is we're going to ask ourselves, how is y changing? How are we going from -6 to -4 to -2 to 0? And if you can't automatically look at that, remember we just talked about sequences and we talked about finding the common difference. You could start at 0 in your calculator and you could do 0 minus -2. Minus negative comes positive and that would give you 2. And then you could do -2 minus -4. And again, you get a +2. So if we look at this rate of change, we are getting 2 bigger every time. We are adding 2 each time. So our next one will be 2, then 4. So the sequences do tie into this slope really well. Here our rate of change for the y is 2. We are getting 2 bigger each time. And now let's find the rate of change or how it's changing for the x. We go from 0 to 1, then 1 to 2, then 2 to 3. You can probably tell on that one without doing it that you are going up by 1 every time. But if you needed to, you could always subtract. You could always do 3 minus 2 is 1, and then 2 minus 1 is 1. You could find it that way as well. So to write our final answer for our slope, we want to do the change in y over the change in x. So just make sure that you put your y values first. Your rate of change for y was 2. Your rate of change for x was 1. So this slope here is 2/1 or 2. Let's look at the next one. And the other thing I wanted to talk about is, so for graph, we usually use rise over run. For t-tables, we usually use change in y over change in x. But you can always, always, always interchange them. And you can always use the slope formula. That's what I wanted to show you on this one. So our slope formula says y2 minus y1 over x2 minus x1. If I wanted to use the slope formula, I would just pick 2 points. I usually like to pick the points that are positive if I have that option. And I'm going to label them. These are my x's up here. So this is my first x, and this is my second x. So x1 and x2. These are my y's down here. So I have my first y and then my second y. And then I plug them into the formula exactly where they look. So y2 is 13, and that goes in the first spot, and then the minus sign. Now I need y1, so I go up here and I find my y1, which is 7. On the bottom, I need my x2, which is 1, minus, and then I find my x1, which is 0, and then I solve it. You can do it in your calculator. 13 minus 7, 8, 9, 10, 11, 12. I just counted on my fingers. That's 6, and 1 minus 0 is 1, and you can reduce this to just 6. All right, so your slope here is 6. You can use this slope formula on every problem. Even if you go back to graphs, you could use the slope formula here by simply writing down the ordered pairs and then plugging them in. So you can always use your slope formula if you want to. It's just another option for you. Oops. Okay, so which has the greater rate of change? Well, I pulled these two from the previous table so that we wouldn't have to redo them. So let me go back and see. This one was 2 and this one was 6. So let me write those down. So here the slope, which we usually let be the letter M, is 2. For this table, the slope is 6. If we have a function that says f of x equals 3, that means when you graph it, well, we'll talk about this one in just a minute. We'll talk about graphing that. Let's go and find the rise over run here. To get from this point all the way up to this point, we have to rise up 1, 2, 3, 4 spaces up and 1 space over. So this slope is 4 over 1 or 4. So I think you can already tell which one has the greater rate of change. It's going to be this graph right here. But I did want to talk about f of x equals 3. So this is a type graph that confuses a lot of people, but basically no matter what value you plug in for x, your y value will always equal 3. So because you can't like do anything over here to the 3, like if you plug in a 1 for x, it's still going to equal 3. If you plug in a 5 for x, it's still. So when you graph this, your y value is always 3. No matter what you plug in for x, the y is always 3. So this is a line that looks like that, which means there is no slope. The slope is 0. Okay, I think that's all for this quiz. Good luck on your slope.